So today we're going to continue graphing exponential functions. Remember that exponential functions are in the form y is equal to a times bx plus c, and x is our exponent. We also learned yesterday that the asymptote is a line that the graph gets close to but never touches or crosses over. And then I put the steps for graphing that we learned yesterday. So we want to use the function to create a table of values, which in this case is already done for you. We have our x's, we can see it replaced and solved for in our equation, and then the output. So for step 2, we want to use this table and plot our points on the graph. So I can go ahead, x is negative 2, y is 0.75, x is negative 1, and y is 1.5. We have x is equal to 0 and y is equal to 3. We have x is equal to 1 and y is equal to 6. X is equal to 2, y is equal to 12, which is off of our graph here. So it also gives us the value for when x is 3, but since it's so far off our graph, I'm not going to bother to put it on here. So for step 3, it's asking us to connect our lines using a curved line. Remember, we're using curved and not straight because these are exponential functions, not linear. So it should look something like that. And again, this is the graph for y is equal to 3 times 2 raised to the x power. So the next question is asking, what is the asymptote? So if we look, and again, if we kept going in the negative direction for our x's, we would see that our y values are getting smaller and smaller, but they are not crossing over our x-axis, also known when x is equal to 0. So in this case, our asymptote is at 0. And again, if I zoom in, and I can make a dashed line, we're never going to cross over the y-axis. I mean the x-axis. We're never going to cross over my green dotted lines. Now in example 2, we have y is equal to 1/2 raised to x plus 3. So again, the table is already completed for us, so we want to go ahead and plot our points. So x is negative 2, y is 7. X is negative 1, y is 5. X is 0, y is 4. X is 1, y is 3.5. X is 2, y is 3.25. And lastly, x is 3 and y is 3.1.25. So again, if I were to zoom in on this graph, I'm getting closer and closer to this line at 3, but I'm not going to touch it, which again is known as our asymptote. So if I draw my dotted line so that we can see it better, and then if I connect my points, you can see I keep getting closer and closer to y is equal to 3, but I'm not going to touch it. So in this case, our asymptote is at positive 3. Now, yesterday we graphed the equation y is equal to 2x and y is equal to 1/2 x, and both of them are shown here. So if we look at these two examples from yesterday and the two examples we just graphed, if we look for patterns, any similarities or differences. So let's see, if I zoom out so we can see at least three of our graphs here. One similarity is that they all have an asymptote. No matter what, they are going to be approaching some value that they will never cross. We can also see that in some of these graphs, we are going in a downward direction from left to right, like this example here and here. But there's other examples where it's going up from left to right. So this example, and then if I move back up, this example also. So the next question says, if we compare the exponential equations to the graph, what do we notice about the base number? And remember, the base number is a number that's raised by x. So let's see, if we look at these two, our base number here is 1/2. And if I look at my graph, it's going down from left to right. And over here, our value for b is 2, and it's going up from left to right. If I look at my other examples, again 1/2, and we're going in a downward direction from left to right. In our first example, 2 is our base number, and we're going up from left to right. So if we look, we can see that when it was a whole number, so we had 2's as our base number, we went up from left to right, but when it was a fraction, or less than 1, it was going downwards from left to right. So there is a rule that we can use that we'll look at later on, but see if you can figure it out yourself to start off with, if we notice anything. The last question is, what do we notice about the asymptote when we compare graphs with the equations? So for both of these two examples here, the asymptote is 0, because we're never crossing over our x-axis here. But let's see, if I look up here, example 2 that we did, our asymptote is at +3. I'm never going to go over it. And our equation is y is equal to 1/2 x plus 3. And if we look at the first example, again, the asymptote is at 0, and our equation was y is equal to 3 times 2 raised to the x. So these three questions down here lead us into the next section of notes. So we have exponential growth and decay and asymptotes to talk about. So again, we know that exponential functions are in the form y is equal to a times b raised to the x power plus c. And if you figured out the rule from earlier, we have if b is greater than 1, then the function has exponential growth and is increasing. So it's going up from left to right. So if I look at the examples we have, right here, 2 is greater than 1, and we're going up from left to right. Now, if our b value, the number being raised to x, is less than 1, which is the example here, is 1/2 raised to x, we're going down from left to right, which is also known as exponential decay, and our graph is decreasing. So, with this information here, we can look at exponential functions and determine if they have exponential growth or decay without even graphing them. So my first example here, y is equal to 1/3 raised to x. It has to be exponential decay and decreasing because b is less than 1. b is 1/3. So because of that, it is exponential decay. But if I go ahead and look at example 2, we have y is equal to 5 raised to the x power minus 3. So let's see, b is 5, which means it is greater than 1. So we have exponential growth, and it is increasing. So without even graphing, we can look at the equations and determine if they have exponential growth or decay. Now, with asymptotes, again, our equations are written in y is equal to a times b raised to the x power plus c. Our asymptote is c. So if I go back up here, we don't have anything that's plus c, so we can assume that it's plus 0 on both of these, which our asymptote is at 0. If I scroll back up to example 2 that we have shown, we do have a plus c right here. It's plus 3. And remember, we said our asymptote was at 3. So you can follow that rule to determine the asymptotes without even graphing. So in this example down here, again, I have y is equal to 1/3 raised to x. Because it doesn't have plus or minus anything, our asymptote is 0. But in example 2, y is equal to 5 raised to the x minus 3. Minus 3 is our c value, so the asymptote is a negative 3. Then for independent problems, there's 5 here. For the first 3, it wants to know if it's exponential growth or decay, so we're looking at our b's. And we need to determine what the asymptote is without graphing. So we want to look to see if it's plus or minus anything. Then our last 2, there are graphs. And you just want to look at them and either highlight if it's exponential growth or decay, or circle it, whatever you prefer. And then we have our exit ticket.